Scientists are creating this to attack cancer cells directly. Scientists and researchers have found a technique through which a patient's immune system can be trained to identify and kill cancerous cells. Immunotherapy is no longer treated as an alternate form of cancer treatment. Researchers have now included various types of immunotherapies in modern-day cancer care. Scientists also have continued with their research on finding newer types of immunotherapies that could help in treating cancer, the latest among which is treatment using nanoparticles. Nanoparticles are trained to identify and kill cancerous cells. Doctors extract proteins and lipids from the patient's cell, which is then engineered to set nanoparticles. The proteins assist nanoparticles to get into the bone marrow, where innate immune cells are formed. An article published on the National Cancer Institute mentions the following. As indeed, the nanoparticle was soaked up by innate immune cells in the bone marrow and spleens of both mice and monkeys. The immune cells then showed several hallmarks of trained immunity. For instance, they divided rapidly, responded quickly to threats, and produced certain chemicals called cytokines that ramp up the immune system. The researchers also tested nanoparticles in mice with melanoma. These melanoma tumors typically have more pro-cancer immune cells than cancer-killing immune cells, what's known as an immune suppressive microenvironment. The human immune system is divided into two halves, innate and adaptive. The innate branch of the immune system works as the first line of defense, whereas the adaptive branch has a more specific and long-lasting effect on foreign bodies. The adaptive branch includes T cells and antibodies, which most immunotherapies use to engage to fight cancer. From CAR T cell therapy to checkpoint inhibitors, immunotherapies are based on the adaptive branch of the human immune system. The newly developed nanoparticles use the body's innate branch to fight cancerous cells. Nanoparticles alter the innate branch of the immune system, making it more powerful temporarily. This temporary state of the innate branch is also known as trained immunity.
So these are very, very small particles that have advantages of high surface to area ratio. And what we've done in our lab is to essentially encapsulate gold nanorods with tyrosine kinase inhibitors in order to help address the hydrophobic nature of this drug.
The National Cancer Institute article mentions the following. Trained innate immune cells are more alert, so they respond more efficiently to infections and cancer, explained lead investigator William Mulder, PhD of the Icahn School of Medicine at Mount Sinai. The innate immune system can stay in this trained state for months to years, giving the researchers reason to believe that the anti-cancer effects of the nanoparticle may last for a while. In the next episode, we will explore another kind of treatment that have got researchers excited. How did you find this information? Please mention this in the comments section. We would also like to know the kind of content you want to watch, and we will try to create it for you. For more news and updates, follow Airr News.